Hi, everybody. Today is Sunday, September 10th, 2023. My name is Michael Zornick, and we are back here at Exercism on the JavaScript track. And today we're going to be learning about Booleans and then working on Annalyn's Annalyn's infiltration example exercise. I don't know. Let's just get started. Oh, wow. This is really terse. A Boolean represents one or two values, either true or false. Logical operators bang, and, or pipe, pipe are generally used with Boolean values, and they return a Boolean value. That is really low. So they also link the MDN web docs, which talk about order precedence and all kinds of stuff. Anyway, all right. Well, that was the quickest learning chapter you probably ever see. All right, so I'm going to download the exercise here. So let's open up a terminal, and we'll use the Exercism command line to download the example. And then we will change directories into the example. And then I'm going to use npm to install. All right, npm is done installing. I will open this up in my VS Code editor. Before I do that, I'm going to briefly start to read the instructions here. In this exercise, you'll be implementing the quest logic for a new RPG game. A friend is developing. The game's main character, Annalyn, a brave girl with a fierce and loyal pet dog. Unfortunately, disaster strikes as her best friend was kidnapped while searching for berries in the forest. Annalyn will try to find and free her best friend, optionally taking her dog with her on this quest. Oh, I thought her best friend was her dog. I was reading it. After some time spent following her best friend's trail, she finds the camp in which her best friend is imprisoned. It turns out there are two kidnappers, a mighty knight and a cunning archer. Having found the kidnappers, Annalyn considers which of the following actions she can engage in. Fast attack. A fast attack can be made if the knight is sleeping, as it takes time for him to get his armor on, and so he will be vulnerable. Spy. The group can be spied upon if at least one of them is awake. Otherwise, spying is a waste of time. Signal prisoner. The prisoner can be signaled using bird sounds if the prisoner is awake and the archer is sleeping, as archers are trained in bird signaling so they could intercept the message. Free prisoner. Annalyn can try sneaking into the camp to free the prisoner. This is a risky thing to do, and she can only succeed if one of two ways. If Annalyn has her pet dog with her, she can rescue the prisoner if the archer is asleep. The knight is scared of the dog, and the archer will not have time to get ready before Annalyn and the prisoner can escape. If Annalyn does not have her dog, then she and the prisoner must be very sneaky. Annalyn can free the prisoner if the prisoner is awake, and the knight and archer are both sleeping. But if the prisoner is sleeping, they can't be rescued. The prisoner would be startled by Annalyn's sudden appearance and wake up the knight and archer. Wow, this is some deep storytelling here. You have 4 tasks to implement the logic for determining if the above actions are available based on the state of the 3 characters found in the forest and whether Annalyn's pet dog is present or not. All right. So, all that said, let's get some stuff open here. So I want to open up the README on this side, and I can make it a little bit bigger. No, I don't want a new file. I want to hide. Oh, I don't want to bold. Oh, this happened last time. I don't want to bold. I want to hide. All right. So let's look at number 1. Implement a function name. Function named can execute fast attack. Oh, actually, before I do that, I want to turn off. Oh no, it is off. Okay. I want to make sure Copilot's turned off. Implement a function can execute a fast attack that takes a Boolean value, which indicates if the knight is awake. If this function returns true, if the fast attack action is available based on the state of the character, otherwise return false. As an example, if knight is awake, true comes in, and it's false. Okay, so this is like really involved here. So that would just be return the opposite of knight is awake, correct? All right, let me let's see. Okay, that looks good. Looks like it's passing. Number 2, check if the spy action. Actually, you know, I'm gonna put the test down here. Keep like fiddling with layouts. Check if the spy action is possible. Implement a function named CanSpy that takes 3 Boolean values indicating if the knight archer and the prisoner respectively are awake. The function returns true if the spy action is available based on the state of the characters. Yeah, this is like getting really complex. CanSpy. Alright. Let's look at the test to help kind of like drive our logic here. So if they're all false, then it returns false. If, all right, man, I gotta reread the story here. Ugh. This is like part of the Exercism track that like I appreciate that they want to add a little bit of story, but this feels like excessive. But at the same time, like when you're working with businesses, they will tell you bizarre, excessively detailed stories that you're gonna have to build logic for. So maybe it is good, you know, to do it. Okay, spy. The group can be spied upon if at least one of them is awake. Otherwise, spying is a waste of time. Okay, so we need to verify if any one of these is true. What is the best way to do that? I mean, you could do it with the very verbose, like return knight is awake equals true, or, you know, archer is awake equals true, or prisoner is awake equals true. True. I spell true right. And I mean that works. I mean it's not particularly elegant, but it does, you know, because you only have 3 items, like it's not aggressively hard to read codes. I'm just gonna leave it like that. Alright, let's go on to number 3. Check if the signal prisoner action is the signal. I thought they were trying to say single. Implement a function named CanSingle prisoner that takes 2 Boolean values indicating if the archer and the prisoner respectively are awake. The function returns true if the signal prisoner action is available based on the state of the characters. Alright, so let me jump back up here. If the prisoner can be signaled, using bird sounds if the prisoner is awake and the archer is sleeping. Okay, so that's like an and thing here. So like if prisoner is awake, I'm gonna say equals true. Like this is the thing, like when you're building this, like and I'm gonna do an and here. Oh, I don't need the if thing. I need return. Prisoner equals awake and archer is awake equals false. So like you could definitely write this as just like this. Well, let's verify. So like signal looks like it's all passing. So I could probably rewrite it by just saying like this. Yeah, and they still pass because like this is still true, and then I mean you could actually like so the other way to do this is like write it like that. That's a little bit more terse. And in that vein, I guess you could just like you could get rid of all of these. So like you could just say if knight is awake or the archer is awake. I mean the way the variables are in, I guess that reads pretty good. Oh. Alright, let's try number 4. Check if the free prisoner action is possible. Implement a function named CanFreePrisoner that takes 4 Boolean values. The first 3 parameters indicate if the knight, archer, and the prisoner respectively are awake. The last parameter indicates if Annalyn's pet dog is present. The function returns true if the free prisoner action is available based on the state of the characters. Otherwise returns false. Okay, so let's see here. Can free prisoner. Annalyn can try sneaking into the camp to free the prisoner. This is a risky thing to do, and it can only succeed in one of two ways. If Annalyn has her pet dog with her. So let's just start this. If a pet dog is present, else. So if pet dog is present, if Annalyn has her pet dog with her, she can rescue the prisoner. If the archer is asleep, archer is asleep, and the knight the knight is scared of the dog, and the archer will not have time to get ready before Annalyn and the prisoner can escape. Okay, so I think that's just that. And then this one, if Annalyn does not have her dog, then she and the prisoner must be very sneaky. Annalyn can free the prisoner if the prisoner is awake. Return prisoner is awake, and the knight and the archiver are both sleeping. And well, because this is I guess you could just say archer is not awake, and the knight is not awake. You could probably, like, the way the logic is described in the story, I feel like I would put those both there. I don't think you need them technically, but I would do them there. Sleeping, they can't be rescued. The prisoner would have to be startled. Okay, so I will save all my stuff, and it looks like all my tests are passing. Wow, there's a lot of tests because there's a lot of there's a lot of variance here in these story modes. Okay, that looks good. So let's see if we can submit Infiltration. Let's see what the internet has to say about our code. Looks good. I'm going to mark this as complete. I'm going to publish my iteration. We've learned Booleans. We've unlocked some stuff. Dig deeper. I doubt there was going to be dig deeper if the learning lesson was so short. Then we've got some community solutions. So, yeah, this looks like pretty close to what ours was, where they're just banging and listing the Booleans rather than checking for like explicit equals equals true, which, you know, seems reasonable. I don't like this, like, return, like, the problem with this is, like, this is very hard to read. Like, you read these two lines, like, return and these parentheses, and, like, it takes a lot of mental energy to kind of load in what is going on and kind of understanding it. Whereas, like, you know, my thing, like, if pet dog is present, return, like, having it treat out like this, and even the parentheses here, I feel like make it easier to understand what's going on, but it's kind of personal preference. Cool. All right. I think that's it. So that's it for Booleans. We are Boolean masters. I guess in the next one, we'll probably talk about arrays and Eliza's enchantments. Eliza. I don't know these names very well. But yeah, we'll probably get into arrays. And yeah, I don't know. That's it for today. Hope you had a good time. If you have any feedback or questions, please do let me know. Other than that, I will see you in the next one. Bye-bye.